Now let us consider the following problem. Use the given conditions to write the equation of the line in point-slope form and slope-intercept form. Here we're given a point, 7, 5, with x-intercept equal to 1. So in here we are somewhat given 2 points because the x-intercept here could be thought of as the point 1, 0. And the other point is 7, 5. Now, when you say point-slope form, that is the form y minus 1 equal to m times x minus x sub 1. So to find that, let's just plug in the expression here. Now, but before that, we still have to find the slope first. So the slope m is equal to the change in y minus the change in x. That means you're just going to subtract the y coordinates and also the x coordinates and divide them. So you have y sub 2. So for instance, we can pick this as your x sub 2, y sub 2, doesn't matter. You can have 5 minus 0 divided by 7 minus 1. Okay, so this is equal to 5 over 7. Again, double check. Change in y. You would subtract the y value. So 5 minus 0 and then 7 minus 1. Oh, 7 minus 1 is 6. Then you can now plug it in. So let's plug it in here. We have y minus, now pick your y sub 1. If I let this be my x sub 1, y sub 1, or you could also use the other one, right? So for instance, in this case, I made this point here as my x sub 1, y sub 1. So I'll just have y minus 0 equal to the slope that I got is m 5 over 6, x minus our x sub 1 was 1. This is the point slope form. Now, for instance, you can also have your answer or y minus, you can choose also the other point. So y minus y sub 1, if I have that as y sub 1, so I could also have y minus 5 over 6 times x minus 7. Both of these are correct. Okay, so then next is to write it in the slope-intercept form. What do you mean by slope-intercept form? That is of the form y equal to mx plus b form. That's the slope-intercept form. Now to obtain this, you just need to simplify your expression here. Okay, you just need to simplify both of these. So I would just pick the first one because the y1 here is already 0. So that means this is now y equal to 5, 6, x minus 1. Now when you simplify that, you just have to distribute that to each term in the parentheses. So you have 5, 6x minus 5 over 6. So y equal to 5 over 6x minus 5 over 6 is the slope-intercept form of your line. Next problem. Rewrite the given equation in slope-intercept form and then give the slope and y-intercept and use the slope and y-intercept to graph the linear function. So let's go ahead and solve that. So let's rewrite that in slope-intercept form. So slope-intercept form is of the form y equal to mx plus b. So if you have 5x plus 9y minus 45 equal to 0. Your goal is to move everything that does not contain y to the other side of the equation. So that means you move this 5x to the right-hand side and also this negative 45 to the right-hand side. So you have 9y equal to negative 5x plus 45. Then you can divide both sides of the equation by 9 to only have y on this side, because you know the coefficient of y is 1. So you cancel 9. So you have y equal to now negative 5 divided by 9. So that means you divide each term in the numerator by 9. Negative 5 divided by 9 is just negative 5 over 9. So you have negative 5 over 9x plus, to get the b, you divide 45 by 9. So divide 45 by 9. 45 divided by 9 is 5. So this is the equation in slope-intercept form. Letter B, what is the slope? So according to that form, the slope is the coefficient of x. It's this value here. That's a coefficient of x. So that is negative 5 over 9. And the y-intercept is actually the b. b here is the y-intercept. So in this case, b, that's the y-intercept, is equal to 5. The next, use the slope and y-intercept to graph the linear function. Okay, so let's graph that. Suppose here, although you have a different, graphing tool, but this is the idea. So what you would do is you start with the y-intercept. So that would be your point, starting with that y-intercept, which is 5. So you have 1, 2, 3, 4, 5. So starting at this point. Then you use the slope. You use the slope here. Now that means it says here negative 5. So negative 5, that means from this point here, from that point, you go down 5 units. So 1, 2, 3, 4, 5. So you stop here. Then you look at the denominator, which is 9. The denominator is 9. So from that point, you go 9 units to the right. 1, 2, 3. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this point here. Then you draw the line passing through those 2 points. That is the graph of this line here. Now moving on, we are given here the graph of a function f of x, and we want to use this graph here to graph the function g of x, which is equal to f of x minus 1. Here we're going to use transformation. So from f of x, this is f of x, we want to obtain g of x. To do that, since g of x is equal to f of x minus 1, that means that we are going to translate f of x along the y-axis 1 unit down, because this is negative. So that means you're going to move this line here 1 unit below. So the line will be from negative 2 to 2. So it is this line here. Letter C. Next. So in this next example, we are to, given the graph of f of x, we are to obtain the graph of g of x, and g of x is just equal to f of x plus 2 minus 4. All right, so let's use translation. Now this x plus 2 here, that plus 2 there, that means a change in x. That means that there is a horizontal shift of 2 units, because this is plus 2, 2 units to the left. So if it's positive, that is to the left. So if you're going to start with your f of x, you're going to move this 2 units to the left. So this point here will go 2 units to the left. So it will go here. And this point here will go here. So this is the new curve. When you apply that x plus 2 will be this line here. The next, we still have to perform this minus 4 here. That means a vertical shift. So you're going to do vertical shift 4 units down. So this new graph here will be moved 4 units down. So you have 1, 2, 3, 4. 4 units down. So it will be this curve here. So this is the final graph of, or that is your g of x. That would be your g of x. And where is that? It is this graph here. Now moving on, we are going to use the graph of f of x to graph the function g of x, where g of x is equal to f of negative x minus 3. Now, let's examine the transformation here. This negative x here, that means that there is a reflection. So this is reflection about the y-axis. And then the negative 3 here means a vertical shift. Of 3 units down. Now, if you have multiple transformations, you would have to follow this hierarchy here. H, R, V. So that means you do horizontal. If there is like horizontal shift or translation, you do that first. The next would be the reflections. And then you can apply reflection along X or along Y, and then you do the vertical shifting last. Now, if you follow that order, you would always arrive at the right answer. Now, in this case, it only involves reflection and shifting. So we do the reflection first. So first, our curve, let's just, to reflect this, that means you're going to, for instance, this point here, negative 4, this point, negative 4, 0, that would go to this point here, positive 4, 0. And then this point, negative 2, 3, will go to the point positive 2, 3. So it will go here. Because when you say reflection about the y-axis, okay, so this goes there, and this point here goes here. Okay. 2. All right. Then your new curve, the new graph, will be, and then of course this point here, hold on. This point, as I've mentioned, this point goes here and that point goes there. So that means we have this point here and it will go that way. And then this will just stay because that is just 0, 0. Then connect to that and then here. So the black curve here, or the black graph, is the new graph after you reflect this function f of x about the y-axis. Then next, you're going to move this 3 units down. So you're going to move this 3 units down. So this point will go 1, 2, 3. It will go here. And then this point goes 1, 2, 3. Now this point goes 1, 2, 3. This one goes 1, 2, 3. And this goes 1, 2, 3. They will all go down. And then you connect them. So let's connect them. So this will be this, that, and then that. This is your g of x. That's your g of x. And where is that? It is this function here. So letter D is the correct answer. Okay, so for the next example or next question, we are given the graph of f of x below, and we want to obtain the graph of g of x, where g of x is just equal to 4 times f of x. So the 4 that is multiplied to f of x here means that we are going to multiply the y-coordinate. So that means, for instance, this point here, the x will be retained, the value for x will be retained, and then the y-coordinate will be multiplied by 4. So this negative 7, 0 will still go to negative 7, 0. So if you look at the choices, you should be able to find, so let's look at those choices. Let's examine them. So negative 7, 0 would still be on the curve. So 1, 2, 3, 4, 5, 6, 7. Looks like, yeah, this is negative 7, 0. All right, so now, so let's just look at each of these points here and see where they go. So as I've said, that the negative 7, 0, that is from your f of x, onto your g of x, that will go to negative 7, 0 as well, because you just need to multiply the y-coordinate by this number here. And then this negative 2 will go to negative 2, negative 8. Multiply the y-coordinate by 4. Then 0, 0 will still 0, 0. Then 2, 2, again, multiply the y-coordinate by 4, so yeah, it's 2, 8. And then that 7, 0 would still be 7, 0. So now we would look at the curve or the curve here that would contain these points here. Looks like, yeah, those are the points. So you just have to check on these 2 points here. So we are looking at negative 2, negative 8, negative 2, negative 8. So let's look at the graph. Here, negative 2, so this is negative 10. Not that one. What about here? That's the right one. Negative 2, oh, it should be negative 2, double check. 1, 2, negative 2, negative 8, and positive 2. 1, 2, positive 2, 8. So it is this curve here. Let's just check this one. What is this? Oh, okay, but this one is up to 9. And that's also, it should be 7, 0. 1, 2, 3, 4, 5, 6, 7. So it should be this point here, right? So we have to be careful. Again, the right answer will be this curve here because it has 7. So 1, 2, 3, 4, 5, 6, 7, negative 7, 0. And then you also have 7, 0. 1, 2, 3, 4, 5, 6, 7. Then we have the point, negative 2, negative 8, and 2, positive 8. So this is the correct answer. Now let's consider another example. In this example, we are given the graph of the function f of x, shown here, and we are to obtain the graph of g of x, where g of x is equal to f of 2x. Now, notice that the 2 here is being multiplied to x, and that is inside that function. That means that the change is along horizontal. Now, also, if you recall, if the change is along horizontal, say for instance, if you remember f of x plus 2, that means that your graph f of x is shifted 2 units to the left. So it goes to the opposite direction. Now, what about if it is f of 2x? Does that mean that you multiply x by 2? No. This means that you divide x by 2. So again, the 2 here means you divide your x coordinate in your graph in f of x by 2. So in other words, if, for instance, you consider the points on f of x, you have negative 6, 0. That point will correspond to, in your g of x, that will correspond to negative 3, 0. So you retain the y coordinate and the x coordinate will be divided by 2. Again, not multiplied by 2, but divided by 2. And so the negative 4, negative 5, negative 4, negative 5, that will go to negative 2, negative 5. Divide the x coordinate by 2. So 0, 0 will remain, 0, 0. That will still be 0, 0 because 0 divided by 2 is 0. Now, the 4, 5 will go to 2, 5. And the 6, 0 will go to 3, 0. So that means if you examine the points, it will behave the same way as this, but it's just shrinked in the horizontal direction. So kind of looks like this would be the graph. So they behave the same way. So it's a little bit shrinked. So let's take a look at the points there. Let's expand this. We are looking at negative 3, 0, negative 2, negative 5. So negative, let's see, negative 3, 0, negative 2, negative 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so, and then 2, and then also 3, 0, 0, 0. And that is also 1, 2, 2, 5. 1, 2, 3, 4, 5. So it is this graph here. The answer is letter C. That is the graph that contains the points here. Okay, next question. Use transformations of absolute value function to graph the function. Now here we just have to select what transformations are needed to obtain the graph of g of x and select all that applies. So because we have negative here, that means there is a reflection. So, but where is the reflection? Is that reflection about the x-axis or the y-axis? Since the x is not inside x, so it's not beside x, or the negative is not beside x, that means that is a reflection about the x-axis. So it's reflection about the x-axis. And the positive 3 here, meaning it is a horizontal shift of 3 units to the left. And this is also a vertical shift of 5 units down. Now, when do you have horizontal shrink or stretch? That is if you have a coefficient to your x. If x is being multiplied by a whole number, that means it is stretched. If it is multiply, if it's multiplied, if x is multiplied by a whole number, you have a horizontal shrink. If it is multiplied by a fraction less than 1, it is a horizontal stretch. Now, you will have a vertical shrink or stretch if you multiply the absolute value by a constant. So if you multiply it by a constant greater than 1, you would have a stretch. If you multiply it by a fraction less than 1, then you have a shrink. Like for instance, in the following question here, use transformations of the cube root function to graph this function here. And you're asked to determine what transformations are needed to graph this function. Now, because the 1/3 here is being multiplied to the cube root of x, so outside of that cube root sign, and that is less than 1, so that means you have a vertical shrink. You will have a vertical shrink by a factor of 1/3. Vertical shrink, so shrunk vertically, where is that? Shrunk vertically by a factor of 1/3. And then the +5 here means it is shifted horizontally because it's plus to the left by 5 units. So the answer is letter A. Let's go ahead and check that answer. And so for the next question, we want to find the domain of this function, 1 over the square root of x minus 13. So to identify the domain, since we have a square root, we know that for this to be defined, the radicand or the expression inside the square root, that is x minus 13, that should be greater than or equal to 0. But then, since this is a fraction, the square root is in the denominator, that means it cannot be equal to 0. So it should just be strictly greater than 0. So x minus 13 needs to be strictly greater than 0. Then x here is greater than 13. And then to write that in interval notation, which what you would be expected to input as the answer, that will be from 13, open parenthesis 13, to positive infinity. Now let's consider this next question. We are given here functions of f of x and g of x, and we are asked to perform the following operations on functions and determine the domain for each function. So first, let's identify what the expression is for f plus g of x. So f plus g of x is just the same as, or it's equal to, f of x plus g of x. In other words, you just have to add them. So you would add 2 minus x squared, that's your f of x, plus your g of x, which is x squared plus 4x minus 60. Then you combine. So negative x squared plus x squared is 0. Then you will have 4x. There's no x here, so that is just 4x. And then we have negative 60 plus 2 is negative 58. Now, to find the domain, recall that the domain of f plus g is just equal to the domain of f intersection the domain of g. So that means, what is the domain of f? The domain of the function f, notice that our function f is a quadratic function. If you have a polynomial function, that means linear, quadratic, cubic, to the fourth power, to the fifth power, and so on, without a denominator, polynomial, there's no variable in the denominator. The domain is always the set of all real numbers. So the domain for f and g in this case, because g is also a quadratic function, is also the set of all real numbers. So the intersection of both is just the set of all real numbers. And the same also for f minus g. F minus g, the domain for that is just the intersection of the domain of f and the domain of g. Now let's compute for f minus g of x. F minus g of x is just equal to f of x minus g of x. So you write down f of x, that's 2 minus x squared, minus, you put it in a parenthesis, x squared plus 4x minus 60. And then you perform the operation. So you have 2 minus x squared minus x squared minus 4x plus 60. Simplify it. You have negative 2x squared minus 4x plus 62. This is your f minus g of x. And the domain for that is also the intersection of f and g. So therefore, the domain of f minus g of x is the set of all real numbers, negative infinity to positive infinity. Next, we are to find f times g. F times g of x. So f times g, or fg of x, is the same as f of x times g of x. F of x times g of x. So this means that you have to multiply 2 minus x squared times x squared plus 4x minus 60. And this is equal to, you just distribute this to each term in that parenthesis and also this term to each term here. So you will have 2x squared plus 8x minus 120 minus x to the fourth minus 4x cubed plus 60x squared. And then combine similar terms. So you have negative x to the fourth minus 4x cubed plus 62x squared plus 8x minus 120. And again, the domain here is the same intersection of the domain of f and the domain of g. So that's also the domain of fg of x is also the domain, the intersection of the domain of f and the domain of g. So this is still negative infinity to positive infinity. Lastly, we want f over g of x. So f over g of x. So you have f over g of x is the same as f of x over g of x. So you just divide them. So you will have 2 minus x squared over x squared plus 4x minus 60. Then let's find the domain. So the domain here is that it's the intersection of f and g, and then, so the domain, for the domain of f over g, that is equal to the domain of f intersection the domain of g, and then you take away the values of x such that g of x is, the denominator is equal to 0. So you take that away. In other words, you cannot have the denominator must not be equal to 0. So we know that the intersection of the domain of f and the domain of g in this case is just a set of all real numbers. So what we want to accomplish now is to find the values for which this denominator is equal to 0. So we want to compute for the zeros of the denominator, x squared plus 4x minus 60 equal to 0. Now, we need to factor this out. So we have x. Now, what are the factors of 60? 60 is 3 times 20. Does not give you 4. What else? 60 is also 10 times 6. And if you subtract 10 and 6, you get 4. So that is what we're looking for. So we have a 10 and a 6 here. Now, which one gets the positive sign? 10 is positive and then 6 is negative, because if you check, you will have negative 6x and positive 10x. Positive 10 minus 6x is positive 4, and that's the middle term. So these are the factors. So we have x equal to 6 and x equal to negative 10. So these are the values of x that will make your denominator to 0. So you don't want that. You want to exclude that from the domain of your function. So if you have the number line here, you don't want it to be, you have a hole at negative 10 and also a hole at 6. So your domain will just be from, so the domain now is just from negative infinity up to negative 10, union, negative 10, so you don't include negative 10, going to 6, union 6 to positive infinity. That's the domain of f over g of x. Now let's consider this example, this number here. You are given f of x equal to x squared plus 6 and g of x, which is equal to the square root of 4 minus x. We are to find f circle g of x, that's the composition of two functions. And then you find the domain of f circle g. Okay, so let's take a look at this problem. So what do you mean by f circle g of x? So f circle g of x, the composition of these two functions. This means f of g of x. That means we're going to use the expression for g of x to replace to the x in f of x. So we have f of the square root of 4 minus x. That means you replace the x here by square root of 4 minus x. So we have square root of 4 minus x, quantity squared, plus 6. And this is just equal to 4 minus x plus 6. So this is then equal to negative x plus 10. Now, next problem is to find the domain of f circle g of x. The domain of f circle g of x is not just simply finding the domain of the resulting function, but rather you want to find the domain of the resulting function. This is the domain of the resulting function. Which is this function here, that's just a line, and then intersection with the domain of the inner function. Which in this case, g of x. So what is the domain of the resulting function here? That's a line, so that means the set of all real numbers. And then you intersect that with the domain of the inner function, the g of x. What's the domain of g of x? So here, the domain of g of x is, that's a radical expression, that's a square root function. So you want that radicand, the expression inside the radical sign, to be greater than or equal to 0. Then you can move the x on the other side of the equation, or you can retain it here. Let's just retain it here. Minus x greater than or equal to 0. And then you move the 4 to the other side of the equation. That makes it negative 4. But we want x, so we will have to divide both sides by negative 1. Now remember, if you divide both sides by negative 1, or a negative number, you have to flip that inequality. Okay, so you have to flip the inequality. This is now less than or equal to. So in other words, this becomes x less than or equal to 4. And that's the same value you get when you just move x to that other side of the equation. That's why I said you can either choose to retain that x on that side or move it to the other side. Since the coefficient of x is negative, I would say, since the coefficient of x is negative, I would say that you just have to move it to that side to make it positive. So you have 4 greater than or equal to x. So that means x is less than x. You read from x is less than or equal to 4. Okay, so how would you do x less than or equal to 4? So you have negative infinity to 4. What's the intersection? To help you imagine it, you could draw it. All real numbers will just be the entire number line. And less than or equal to 4, if this is 4, less than or equal to 4 will be this, and then going to the left. And then the set of all real numbers is the entire number line. So get the intersection, common to both. And that is just negative infinity to 4. So the domain for f circle g of x in this case is negative infinity to 4. Now lastly, let's consider this example here. Use the graphs of f and g to find f times g of negative 2. Now f times g of negative 2, f times g of negative 2 means f of negative 2 times g of negative 2. That's different from composition. That's product. So you're just multiplying their y values. So this means that you're just going to get the y value for the corresponding value for f at negative 2. So look at f at negative 2, and this is f, that's positive 2. So you have 2. And then g of negative 2, that's the red curve. G of negative 2 is 4. So therefore 4 times 2 is equal to 8. So that means f times g at negative 2 is just equal to 8. Now what about this? You are given the graph of f and g and you want to evaluate f circle g at 2. So this is a composition of function. This is not product of function. So composition of the two function. F circle g of 2 means f of g of 2. So what does that mean? That means that you have to get first g of 2. So what is g of 2? Get the g. This the graph for g is the red graph. X is equal to 2. So then you get the y value. So g at 2 is negative 4. So this means this is equal to negative 4. So you're just going to get the value of f at negative 4. So negative 4, this is negative 4 for your f. So that makes it your x, right, for the f. So when x is -4, you get the y value. The y value is 8. So f at -4 is 8. So that means f circle g at 2 is equal to 8.